Hello there and welcome to our fourth video looking at our practical programming paper. In this video, looks like we've got a pseudocode or an algorithm question. So what we need to do is firstly look at the question and break it down. So let's jump straight in. iZone has to maintain strict temperature controls over the skating surface. Using a recognized convention, design an algorithm to help iZone control the temperature of the ice. The algorithm should repeatedly allow a user to input the temperature in degrees Celsius to the nearest 0.1 degree. The algorithm should continuously loop until a rogue value of 100 is entered. The algorithm should compare the value entered to the following set values and output the correct message. And then we've got a series of conditions. A positive number or above minus 2.1 should provide the message temperature too high. Minus 2.1 to minus 4.0 should provide the message suitable for general skating. Minus 4.1 to minus 5.5 should provide the message suitable for competition ice skating. Minus 5.6 to minus 9 should provide the message suitable for ice hockey, and then below minus 9.0 should provide the message fault detected. Your algorithm should be written using self-documenting identifiers. So there's a few bits of information in there that you need to be aware of, or that my ears pricked up actually when I heard certain things from this. So firstly, using a recognized convention, okay? Now recognized convention is either pseudocode, which it mostly is at A-level. You could also, I suppose, use a flowchart for this. And even structured English would also be accepted if they just put using a recognized convention. It says here, the algorithm should repeatedly allow a user to input the temperature in degrees Celsius. So firstly, a couple of things that I'm getting from there is degrees Celsius is going to be a real number. Okay, it's a floating point value, it's going to have decimal points. When it says repeatedly, what I'm thinking about there is I'm thinking about a loop. Repeatedly, repetition, I'm thinking loops. Then it says to the nearest 0.1 degree, so we might have to think also about some rounding. The algorithm should continuously loop until a rogue value. So a rogue value, if you've never heard of that before, is a terminating condition. So if somebody enters 100 degrees, then that is the condition that breaks the loop. And then these are our conditions. Now, when I read these conditions, I was getting a lot of if statement vibes from this. So, for example, I would put their if statement. Now it says a positive number or above minus 2.1. So we're going to have some conditions in here. So we've got an or for this one. Minus 2.1 to minus 4.0. So these conditions here where it says 2, we have to be between that range. And the best thing for range is using the AND logical operator, because it needs to be between minus 4.1 and it needs to be below minus 5.5, or in between those, should I say. So that's where the AND condition comes in. And then finally, we've just got below minus 9. So they're the things that I was getting up from my initial reading of the algorithm. So then let's start piecing this together. Now the way I like to do this, or prepare my pseudocode, is firstly, I'm going to have a section for variables. And what I need firstly is I need an input from the user in order to get the current temperature in degrees Celsius. That's step one. Forget about everything else. Just get the user to enter in the current temperature into my system. So to do that, I'm going to have a variable here. I'm going to call it current temp. And that's going to be of type real, which is my floating point value. Now, one thing to point out here is all my students are trained to create or write in self-documenting identifiers from the get-go anyway. So current temp will really be no surprise to people. It's going to hold the current temp, so it's going to be self-documenting. When I read it, it should tell me what's stored inside it, and that's a self-documenting identifier. So I've got current temp is real, and what I'll do then is I'm going to set the current temp to 100. Now the reason why I'm doing this is because I want to contain this within a loop. So what's going to happen is I want to run this loop first. So literally all I'm going to do is I'm just going to write loop. And at the bottom, I might need to move this later on. But I'm going to say until, and what's our condition for looping? So loop until current temp equals 100. Now what this is this is a post condition loop. So you compare or you check the condition after you've finished a full loop here. Now there's a number of different loops that we can use. A for loop wouldn't work for this because it's a static loop. A do while loop would work because we're going to do while a condition is true. So you could say do while current temp is less than 100, just keep going and just keep looking at it like that, okay? So there's a number of different iterations you could have used, but I'm going with the loop until. So I'm going to do one run through first, and then I'm going to check the value of current temp at the bottom. Now inside the loop, the first step that I'm going to have in here is I'm going to get the user to input the current temperature. And I want to store that inside my variable current temp. So although it's set to 100 here, it's going to change down here. Now the user enters the current temp, and the first thing I'm going to do after they've inputted the current temp is I'm going to have a selection statement. I'm going to say if the current temperature, if current temp is equal to 100, then output program ends. So if the current temp is equal to 100, then that's our rogue value. That's where we end our algorithm. Else, so if it's not equal to 100, what else are you going to do? And all I'm going to do is I'm going to start checking these conditions over here. And I'll just work my way through. So a positive number or above minus 2.1. So anything greater than minus 2.1 is going to say temperature too high. So nice, just a simple if statement just to show that. And make sure, this is a top tip really, make sure you indent. It's much easier for the examiner to read, and it's much easier for you to read as well and keep track of. So current temp is greater than 2.1, then output temp too high. Okay, that's the first one there. Now I know I'm going to run out of space, 100%, I guarantee that. So what I'll do is I'll write else in here, and I'll move this for you so you can see it a little bit better. There we go, that's a little bit better. And now what we'll do is I'll just tick this one off and move down to the next one. Because once we've checked that the current temp is greater than 2.1, that should be negative 2.1 as well. I'll just check the question, negative 2.1, then the temperature is too high. So the next one will be an else if condition, and it will say if the current temp again, so this time current temp, and then you got to look at this now, minus 2.1 to minus 4.0, and it says suitable for skating. So it's exactly 2.1 to exactly 4.0. So here I would put less than or equal to minus 2.1, logical condition for my and current temp is greater than or equal to minus 4.0. Now you've got to be careful with the logic here. We are working with negative numbers, so just think it through very, very carefully. And this is going to say output suitable for general skating, and there we go. And don't forget the if statement needs to end or have a end condition that says then, and then it moves into the true part of the statement which says output suitable for general skating. Now in the next bit we're going to do another else if, and we just follow the pattern down the line. We've done that one now, 2.1 to 4. So we say current temp is less than or equal to minus 4.1, and current temp is greater than or equal to minus 5.5. Then if that condition is true on either side, on both sides, sorry, then what we do is we say output again, output the string, suitable for competition skating. Move straight on to the next one. Else if current temp is less than or equal to minus 5.6 and current temp is greater than or equal to minus 9.0, then output message, suitable for ice hockey, and then we have our final statement, which we could have had an else, but I'll use an else if, so you get to see the whole logic. Else if the current temperature, current temp, is below, so it's minus, below or less than minus 9.0, because it says below negative minus 9.0. Then what we're going to do is we're going to output fault detected. Then we end the if statement altogether. We've got our loop condition. Start off at the top, and that looks pretty good to me. Now, what we'll do is we'll check to see that we've got all of the 8 marks. So 1 mark is going to come from the input of the current temperature. You get 1 mark for the loop. There we are. You get 1 mark for the rogue condition. That's 1 mark for that. 1 mark for that. 3, 4, 5, 6, 7, 8 marks in total. And you also need to look at the overall. Does it work? If you had a different algorithm, this is just one method or one solution. If you had one of these that's different, or you decided to do it a different way, and as long as it reaches the same goal, absolutely fine. You're going to achieve all of the marks for this question. And hopefully that helped you. A little bit of practice on pseudocode for your paper 2, and you'll see me in the next video talking about putting some code down and fixing some issues with code.